Okay, today we are going to talk about the law of cosines. Um, Remember we talked last week about the law of sines that says this. And the law of sines was for angle, side, angle triangles, angle, angle, side triangles, and side, side angle. Very creative name we've got for this one. The triangles look like this, where A, B, and C are angles. Capital A, B, and C, lowercase are sides, and they are across from the corresponding angle. Remember that side-side angle sometimes had two cases. That was when the shorter side and longer side angle, that it would have two cases. We called that the ambiguous case, and you're supposed to solve for both. We also have the law of cosines. We do not have a law of tangents. The law of cosines looks like this. I tend to only use this case. The book's going to introduce a couple other ones where they switch C's and A's or B's and C's. So that looks like, here's one. The key thing here is this one and this one go together. So if I'm solving for A squared, I'm using cosine of angle A. My preference is to just use this top one here and just label it so C is my unknown side. This applies to side angle side triangles and side 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 triangles. You should notice that this part here is the Pythagorean theorem. The law of cosines is essentially the Pythagorean theorem for non-right triangles. Okay, so I'm going to show you the law of cosines for a side angle side triangle. It's pretty straightforward for side angle side. Side 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 is a little more difficult. So I've got this triangle. My angle's a little large. This is not drawn to scale. So here's my angle. We're going to call it C. We'll call this side C. Oh, the book even called it that. I'm surprised. Usually I just label it what I want. So I'm looking at C squared equals 5 squared plus 11 squared minus 2 times 5 times 11 times cosine of 20. And when I work that all out, I get C equals 6.5. Now, they didn't ask me just to find C. They asked me to solve the triangle. So that means I need to find this angle and that angle. I always find the acute angles. So the inverse sine only gives us angles between -90 and 90. So this is probably more than 90. So I'm not going to look for that one. I'm going to look for this one. And I will use the law of sines to do that. You can use the law of cosines to get this angle. It's just way harder. So I don't recommend it. So now I've got 6.5. Sine of 20 over 6.5 equals sine, let's call this A. Sine of A over 5. And then I'm going to do the inverse sine of this whole thing. A lot of times I would do the number on the calculator first, but I don't have a calculator handy. And that'll give me angle A, which is 15.2. And then to get angle B here, I just do 180 minus 20 minus 15.2. And I get 144.8. So there I used the law of cosines to find my first side. My strategy is I always find the other thing parts by law of sines. Usually it's my last, well, I find one angle by law of sines and third one by 180 minus. But remember, it's important to always use the law of sines to find the acute angle. If you're questioning if it's obtuse, find the other angle. Now I'm going to show you law of cosines for a side-side-side triangle. And this one we will use to get the angle. It's a little bit more work. So let's find this angle. We'll call that C, we'll call this one A, and this one B. Again, I don't care what the book labeled them. I'll transpose it later. Oh, hey, I actually labeled it the same. Okay, so that means little c here is 5. Okay, order of operations becomes very important here. Okay, I'm gonna square these out. And I'll multiply these three numbers. 63 times 2 is 126. So I cannot do 49 plus 81 is 130. I cannot do 130 minus 126 because 126 is multiplied by cosine C. So I'm going to subtract 130 from both sides. Again, 130 is 49 plus 81. And that gives me negative 105. And then I'll do the inverse cosine to get C. And I get C is 33.6. I finished solving the triangle. I'm going to do B first. I'm not sure if A is over 90 or not, so I'm just not going to do A. I'll do that by the 180 minus. So by law of sines, and then to get angle B, I will do the inverse sine. And that gives me 50.7. With law of cosines, it doesn't matter if you do 1 over 180 because the inverse cosine goes from 0 to 180. But for law of sines, it's important that you don't do 1 over 90. Or law of cosines, you can't do 1 over 180, but you can do 1 over 90. So measure of angle A is then I subtract, and I get 95.7 degrees for A. It was over 90. It was good that I did B here first. Otherwise, I would have gotten that wrong. So that's the law of cosines. Now you can solve any triangle if you're given a congruent situation. So a side angle side, a side side side, an angle side angle, or an angle angle side. And you can also solve for the two cases if it's side side angle. At worst, two cases. We also are going to talk briefly about two different area formulas. There's the side angle side area formula, which says area equals 1/2 AB sine C. So again, on a triangle, if this C, little c is over there, A, little a, B. So this is side angle side. The other one, known as Heron's formula, is side side side. And this is a little bit of a two-step formula. We start by calculating what's known as the semiperimeter, S. So that's half of the three sides added together. And then the area uses this calculation. There's a proof of this in the book if you want to see it. But I think most of you will take my word for it, that it works. Okay, so I'm going to give you an example of each of these quickly. Um, so it says find the area of a regular octagon with inscribed inside a circle of radius 9. So here I've got an octagon. The radius, if it's a circle, it's going to touch in these corners. So these are 9. I have 8 triangles here. I guess I didn't put my center point quite in the middle. All with sides 9. This whole distance around the circle here on the inside is 360. So each angle here is 45. That means the area of each triangle is 1/2 9 times 9 times sine of 45. That's 81. Sine of 45 is square root of 2/2. This is also over 2, so it's 81 square root of 2/4. I have 8 of those triangles, so I multiply it by 8. That cancels with this and 2. So the area is 162 times the square root of 2. Inches squared, because these are in inches. They also gave the decimal as approximately 229 square inches. Using Heron's formula, I have a triangle with sides 13, 15, and 18. So I start by computing S. Half of 13 plus 15 plus 18. And that is 23. The area is then the square root of 23 times 23 minus 13. That's 10. 23 minus 15, that's 8. And 23 minus 18 is 5. And I just stick all of that into a calculator. I might do square root of 23 times 10 times 8 times 5 in my calculator. Save me a little typing. And that equals, when it's all reduced, 20 times the square root of 23. Okay, that is your lesson for today.